Hello friends, welcome to EPG Padasala. I am Dr. Kappagam Chinnammal from Chikkana Government Arts and Science College, Tirupur. Today we are going to deal with the topic printing with synthetic dyes. What is printing? Printing is a process of applying color to fabric in definite pattern or design. It involves deposition of viscous paste containing the dye stuff, a thickening agent, a small amount of water and other printing assistants. It's immediately dried to prevent the spreading of the color beyond the boundaries of the design. The actual transfer of dye stuff from the thickener film into the fiber of the fabric is carried out by steaming, curing or chemical fixation. In any printed fabric, it's necessary to have excellent color fastness. There are various tests to determine color fastness like washing, rubbing, light, etc. In this session, we would get an insight into printing using different synthetic dyes, be acquainted with the after treatments for printed fabrics, and be aware of the color fastness of various dyes. Styles of printing. There are various techniques of applying color on textiles. Broadly, they may be classified as direct, discharge, and resist. Direct style. This style is also referred to as steam style because in most cases the printed fabric is steamed to fix the color. The color is applied directly to the fabric with the required ingredients, and after printing and drying the color is fixed by steaming or thermofixing. Most of the class of dye stuff are printed on the fabric by the direct style. Next is the resist style. In resist printing, the bleached goods are printed with a pattern in form of resist paste which cannot be penetrated when the fabric is subsequently immersed in a dye solution. Only those portions which are not covered by the resist paste will be dyed. After washing, a white pattern will be formed on a dark background. This is white resist. It is also possible to obtain color resist on dark background by using the dyes in the resist paste which can withstand the action of resisting agents. The third one is discharge style. In this style of printing, fabric is dyed the ground shade and then printed with a paste containing an alkaline reducing agent such as Rangelite C which will destroy the color. This is white discharge. Sometimes the ground color is removed and another color that can withstand the action of the discharging agent is printed to subsequently obtain color design effect. It is then steamed followed by washing to remove the byproducts of the reaction. The dyes have to be selected properly as not all dyes are dischargeable. First, let's look into the direct style of printing using different dyes. Cotton printing with pigments. In printing, dyes used penetrate inside the fabric and get absorbed in the fiber by electrostatic force or chemical bond. In pigment printing, there is no bond formed between fiber and pigment, so they are not fast to rubbing, washing or light. To improve these properties, the printing paste is composed of pigment, a binder, a suitable thickening agent, catalyst, softening agent and auxiliaries. Pigments are supplied as dispersion called pigment emulsions or pigment paste containing surface active agents to keep them in stable dispersion. The binder is a film forming material of high molecular weight and is the most important ingredient in the printing paste and is used for fixation. A thickener facilitates the properties and it must have no effect on handle of the fabric and must be removed easily after curing. A suitable thickener is an emulsion thickener. Catalyst or acid liberating agents to accelerate the cross-linking of binder and to facilitate the reaction between the binder and the substrate. Diammonium phosphate, ammonium sulfate are the most commonly used catalysts. Dimethylurea and dimethylol ethylene urea are examples of cross-linking agents which are not self-reacting. Softening agents improve the handle of the fabric. Dispersing agents and polyalcohols are incorporated in the paste to stabilize the emulsion and prevent it from drying. The sequence of process is print, dry and cure. In this process, a binder emulsion is first prepared and is mixed with pigment dispersion. This paste is used then for printing. The table shows the ingredients for binder emulsion. It consists of acramine SLN, an emulsifier, carboxymethyl cellulose paste and kerosene. Table 2 shows ingredients for reduction thickening. Kerosene, which is not soluble in water, is emulsified by adding emulsifying agent, and all three are mixed and stirred at high speed. The printing paste is prepared using 5 gram of acramine pigment emulsion, 50 gram of binder emulsion, 3% of diammonium phosphate, 2 gram fixer CCl and reduction thickening. The fabric is printed with the printing paste using screen, roller or rotary printing machine. It's dried and cured at 140 to 150 degrees centigrade for 3 to 5 minutes. The paste forms a thin film on the fabric surface, and when cured, the pigments react chemically with the fabric and binds with it. Then the cloth is washed and dried. The advantage of pigments are they are applicable to all kinds of fibers, especially mixtures and blends. High productivity due to elimination of after treatments. High fastness properties. Non-staining of white ground. And availability of complex range of colors. The disadvantages are the use of costly and hazardous kerosene and the lack of fastness to rubbing and dry cleaning. The present trend is to replace partly or fully the kerosene and the print paste with newer products such as acrylic thickeners. Next, let's see about printing of cotton with reactive dyes. Cellulose fabrics are the most commonly printed substrate, and reactive dyes are the most commonly used dyes in textile printing. The application of reactive dyes leads to formation of covalent bond between the dye and fiber, resulting in good wash fastness properties. The dyes are brighter, easier to apply and gives a full range of colors. Sodium alginate is the only natural thickener found suitable for reactive printing. Other thickeners like starch and guar gum react with the dye and lowers the color yield. Sodium alginate produces soft and brilliant prints, but it is scarce and expensive. Synthetic thickeners such as polyacrylic acid, which do not react, have been introduced. Carboxymethylated, that is guar gum, is chemically modified and sold as substitute to sodium alginate. It has great economic and environmental advantages and is characterized by high viscosity and good film forming properties, but it is not a good substitute for alginates. And half emulsion thickening, in which both sodium alginate and emulsion are present, is used. When selecting reactive dyes for printing, the factors of importance to be considered are print paste stability and staining of the ground during washing off. For optimum results, the fiber pretreatment is important and mercerization is recommended. Reactive dyes are applied by two processes, exhausting and fixing. The exhaustion is done under neutral condition and fixation is done in alkaline condition. Reactive dyes have low affinity for cellulosic fibers. However, they can be exhausted into the fiber using exhausting agents like Glauber's salt or common salt. The exhaustion of dye on fiber before the addition of alkali and also the reaction of dye and water leads to hydrolysis or inactivation of dye. The hydrolyzed dye also gets deposited on the fabric surface and gives poor wash fastness. Printing textile with reactive material causes problem because of these hydrolyzed dye. When the fabric is printed with reactive dye, most of the dye reacts with the printed portion of the fabric, but some amount of dye gets hydrolyzed like dyeing. This hydrolyzed dye and the thickener used in the paste has to be removed by soaping. While soaping, the hydrolyzed dye gets transferred to the soap bath and this transformed into dye bath and tints the fabric with dye, and it is clearly seen on white background. Hence, reducing white background fabric with reactive dye printing is difficult. Some reactive dyes get reduced during steaming. So, to protect the dye, 1% resist salt or ludigol on weight of paste is added to the printing paste. Resist salts acts as a mild oxidizing agent. The fixation of reactive dye on the fabric can be brought about by liberation of alkali during steaming process. So, alkali liberating agents such as sodium bicarbonate is added. For fixation of reactive dye, one of the following processes is used, that is steaming, dry heating, flash aging, wet development or silicate padding. In steaming process, a stock thickening using alginate or half emulsion thickening with sodium alginate is first prepared as follows. A thickener stock paste is prepared by adding a thickener powder in a small amount of water, demineralized water, and continuously stirred with a mechanical stirrer until a smooth paste is obtained. The prepared paste is stored overnight. Another paste is prepared by mixing urea in warm water and cooled at room temperature. To this, required amount of dye and other auxiliaries except alkali is added and stirred until a smooth paste is obtained. Calculated amount of prepared thickener stock paste is added to this dye paste. Alkali is added and mixed just before printing. When depth of shade has to be reduced, the printing paste may be diluted by reducing thickener. It can be prepared using urea, sodium alginate, sodium bicarbonate and resist salt in the proportion shown below. The printing paste is then printed, dried and steamed. The sample is printed and printed samples are dried at 90 degrees centigrade for 5 minutes and steamed at 1 or 2 degrees centigrade for 15 minutes. During steaming, sodium bicarbonate decomposes to give sufficient alkaline condition for fixation of the dye stuff. The fabric is then washed thoroughly, first in cold water, then in boiling water for 5 minutes and soaked with 2 gram Lysopol D and boiled for 15 minutes, rinsed and dried. In baking or thermofixing process, a high concentration of urea, normally 200 gram per kilogram, has to be used. The alkali used can be sodium bicarbonate or sodium carbonate. After printing and drying, the fabric is baked at 150 degrees centigrade for 5 minutes, rinsed, soaked with a detergent at boil, rinsed again and dried. Flash aging. In this process, the fabric is printed with a paste which does not contain any alkali and is then padded with an alkaline solution and steamed in the wet condition at 140 degrees centigrade for 30 seconds. In the wet development process, the process is similar to the flash aging process except that the fabric after printing is passed through a hot alkaline solution at 95 degrees centigrade to 98 degrees centigrade for 15 seconds and is not subjected to steaming. In silicate padding or pad batch process, the process is widely used for printing and fixing reactive dyes belonging to vinyl sulfone group, that is the remezols. The method is suitable for use in the cottage industry since the fixation of the dye is brought about by padding the fabric after printing with sodium silicate solution at pH 11.4 to 12, batched and stored for 12 to 14 hours and then rinsed, soaked at boil, rinsed and then dried. Color fastness to rubbing in dry condition is very good and in wet condition. Color change due to washing is fair and staining is very good. Printing silk using acid dye. Silk, as all of us know, is a protein fiber, so acid dye is excellent for dyeing on silk, and guar gum, being acidic in nature, is good for printing with acid dyes. Solvent is used as a hygroscopic agent. Its function is to take sufficient amount of water during steaming to mobilize the dye to get absorbed into the fabric. Urea has dye solubility and hygroscopic property and so is used as an ingredient. Acetic acid is used to give an acidic condition. The printing paste is prepared by mixing all the ingredients and the fabric is printed using block or screen. After printing, it's dried and steamed at 100 to 120 degrees centigrade for 30 to 40 minutes. The steamed fabric is thoroughly washed in cold water and dried. Acid dyes give brilliant shades, good fastness to rubbing and light, and moderate fastness to washing on silk. Printing silk using reactive dyes. The printing paste is prepared by mixing the ingredients given in the recipe. The material is printed by this recipe are steamed at 100 to 120 degrees centigrade for 10 to 15 minutes. The steamed fabric is thoroughly washed in cold water and then washed in 60 degrees centigrade hot water and again rinsed thoroughly in cold water and dried. Hot brand reactive dyes, when used on silk for printing, have excellent brilliant shade and good washing and light fastness. But mild acids are required for fixing these dyes on the fabric. Next, let's see how polyester is being printed using disperse dye. Commonly, disperse dyes are used for printing polyester materials. Combinations of reactive, disperse dyes or wad disperse are for blend printing of cotton polyester. Suitable pre-treatments for the fabric must be employed to remove sizes and the spin finishes before printing. Heat setting is also important pre-treatment. The thickening agents and fixation techniques must be properly selected to produce satisfactory results. Thickeners selected for printing polyester must be taken up by the fabric, forming a thin layer that is locking the pigment on the fabric. And this layer should prevent cracking or dusting away of pigment. It should also give level absorption of pigment and sharp prints. After curing or steaming and during washing, the thickener should be easily removable. The most commonly used thickeners for polyester are starch ethers, guar gum, natural gum and indalca. To prevent the dye from being reduced during steaming or thermofixation, resin salt or ludigol is used and sodium chlorate also works well. Disperse dye gets fixed at pH 4.5 to 5. The printing paste should be slightly acidic in nature, only then disperse dye fixes and produces sharp prints. If the paste is alkaline in nature, the dye loses its affinity and produces dull color print. To make the paste acidic, glycolic acid, tartaric acid or ammonium sulfate is added. Leveling agents and carriers could also be added. Disperse dyes on polyester can be fixed by 3 methods, which are pressure steaming, high temperature steaming and thermofixation. On the basis of sublimation of dye on fabric, the method of fixation is being selected. Thermofixation is used for dyes with fast sublimation. Pressure steaming is used for dyes with moderate sublimation. Pressure steaming. By adding 30 to 60 gram per kilogram a carrier and steaming for 20 to 40 minutes in saturated steam at 100 degrees centigrade gives acceptable fixation with selected dye. High temperature steaming. In this method, the steam temperature is raised to 180 degrees centigrade at atmospheric pressure. The printed fabric is continuously passed through steamer for 1 to 2 minutes, depending on the speed of fabric movement. Because of high temperature steam, dye gets fixed in short time. Thermofixation is a continuous process. In this, the printed fabric is carried on stenter and passed through hot air of 200 to 210 degrees centigrade temperature for 20 to 30 seconds. The color yield of the print are not bright when compared with steaming method. So in the table you can see comparatively the 3 methods. The printing paste is prepared by mixing the ingredients as shown in the table 8. The quantity of each ingredient is based on the fixation technique. The fabric is printed, dried and fixed by any one method described earlier. After treatment, washing is done to remove thickener and unfix disperse dye. Thorough rinsing in cold, then warm water should be followed by an alkaline reduction treatment at 40 to 50 degrees centigrade Example, 1 gram per liter surfactant, 2 ml per liter sodium hydroxide, 1 to 2 gram per liter sodium hydrosulfide. Finally, the goods are rinsed in warm then cold water and dried. A softener or antistatic agent may be applied in the final rinse or by padding before drying. Disperse dyes have good fastness to all agents. Printing of acrylic fabric using cationic dyes. For printing acrylic fabrics, cationic dyes are used, and this class of dye gives sharp prints, good washing, rubbing and light fastness property. The printing paste is prepared by mixing the ingredients shown in table 9. The printed fabric is steamed for 20 to 30 minutes at 105 to 115 degrees centigrade. The steamed fabric is rinsed thoroughly to remove unfixed dye. To prevent the ground fabric from staining, it can be rinsed first with cold water and then with hot water with wetting agent for 25 to 30 minutes at 60 degrees centigrade. The fabric is removed, rinsed with hot water, followed by cold water and lastly dried. Khadi printing. In this printing, the dyed fabric is printed with a paste containing white pigment, that is titanium dioxide. White print is produced on a colored background. Also, colored khadi can be produced by adding small amount of pigment in the paste and printing on white fabric. Khadi printing paste is prepared using the ingredients shown in table 10. Khadi has no affinity for cotton, and so a binder has to be used to trap the pigment between the binder and fabric, forming thin film. The pigment gets fixed on the fabric by curing the chemical reaction, binder film and using a fixing agent. The printed fabric is dried and cured at 130 to 150 degrees centigrade for 3 to 5 minutes. Discharge printing. White discharge style. White discharge paste is prepared using the ingredients in table 11. The fabric is first dyed with azoic colors, that is naphthalization and coupling with dyes base, and is then printed with a white discharge printing paste, dried and steamed at 100 to 103 degrees centigrade for 5 minutes and immediately treated at the boil for 4 to 5 minutes in soda ash to remove the decomposition product as well as the thickener and chemicals. It's followed by soaping treatment. Color discharge style. Fabric dyed in azoic color is printed with discharging chemicals which during steaming produce alkaline and reducing condition. At this condition, azoic colors present at the printed portion reduces and discharges color and gives white portion. For producing color discharge effect, another color dye can be added to the printing paste. But such dyes which require alkaline reducing condition to fix on the fabric only can be used. Since vat dyes need alkaline reducing condition for vatting and fixation in cellulosic fiber fabrics, discharging of azoic colors as well as the vatting of vat dyes can be done simultaneously in vat color discharging printing on azoic ground. Color discharge paste is prepared by mixing the ingredients shown in table 12. The printed cloth is dried and steamed for 5 minutes at 100 to 102 degrees centigrade, rinsed, oxidized with sodium perborate and acetic acid, soaked at boil, washed and dried. Discharge printing could be done using other dyes like reactive and disperse also. Resist printing. Since reactive dyes require an alkaline medium for fixation, it can be prevented by printing with acid, that is citric acid or tartaric acid. After this, the fabric is washed to remove unfixed dye from the printed area. It is suitable only for dyes with low affinity. Hence, thickeners used must be acid resistant. Locust bean gum and tragacanth are suitable for this purpose. The process is done in 2 steps. Firstly, white resist paste is printed and secondly padded with paste containing alkali. The white resist paste is prepared by mixing citric acid, carboxymethyl cellulose and water. Color resist paste is prepared by mixing reactive dye, resist salt, water, sodium bicarbonate and carboxymethyl cellulose. The padded fabric is steamed at 100 to 102 degrees centigrade for 7 to 10 minutes. The fabric is rinsed, soaped, rinsed and then dried. So let us summarize about printing using synthetic dyes. So today we dealt with printing using the three styles, that is direct, discharge and resist. I have just given you a few examples, but you can also do resist using other dyes, discharge using other dyes and so on. So all of us know a plain fabric or a dyed fabric is monotonous and printing is an embellishment on fabric, and there are various types of printings like block, screen, stencil, roller, rotary, etc. In this module, we have dealt with printing using various synthetic dyes, their after treatments and color fastness properties.